So this is the back of the sheet we did today. The sheet we did today should have some good examples on how to do this. I think what I'm going to do is just get you started on everything. I'm not going to finish. I'm not going to finish it completely, unless that just accidentally happens. So let's sort of just get started and do a little bit of it, and then you fill in the rest. It shouldn't be too hard after I give you parts of it. So what we're going to do first is talk about minutes versus hours, and that's all you had to do. You're not doing part B, you're just doing part A, this part here. So let's talk about this. Now we need to know for one first. That's a good place to start. That's right here if you didn't see that, for one. Well, we don't have any information there, but if I look here, we do have that it's 300 minutes for 5 hours. So can anyone tell me what to do to find for one, the unit rate? How do you find the unit rate? I see some hands. Good. Toby?
Divide 5 by 300 and get 6.
Yeah, just your y divided by your x in this case. 300. Your unit rate's 300 divided by 5, which is 60. So 1 hour would be 60 minutes. So 2 hours would be how much? 120. Right. And then if we come to here, let's see, we did 2 times 60 to get this. So what are we going to do to get from 720 to this number? What's the opposite of multiplication? Yeah, division. So we have 720. And what do we multiply by to get from here to here? 2 times what makes 120? 1 times what makes 60? 60. So we're going to divide by that 60. And what's 720 divided by 60? You can use a calculator. 12? Is that right? Okay. So you're going to fill in these other missing numbers. I'll let you do that on your own. And if you look here, what do we do every time to get from the x to the y? From 1 to 60, 2 to 120, 5 to 300. What did we always do?
60.
We multiply by 60. So here I'm going to put 60 times x. 60x. Any questions about that part? All right, if you look at the ratio from the back side of this page, it'll make sense. Basically, you're just putting your y over your x. So, like, look here. What's the y value? On this one, what's the y?
60.
60. What's the x?
1.
1. Let's do it here too. What would it be here?
120.
What's the x?
2.
2. And if you divide all these, what are you going to get?
6.
60. So what's the unit rate? 60. And we can do it as minutes. Minutes per hour. So what did you do to find the number of minutes in a given number of hours? What did we do to find the number of minutes for each hour? We multiplied. By the unit rate, by 60. Any questions so far? All right, since this is a proportional relationship, tells us right there, what is the equation form? It starts off with y equals. What's the next part? For direct variation or direct proportion? No? You weren't. Anyone who was in our first 2 periods, remember? Matt? Close. K what?
KX.
K times x. Thank you, both of you. Kx. And K is our constant, which is just another name for now. It's another name for what?
Unit rate.
Unit rate. It's the same thing. Now, like I told you earlier today, there's this. Next year they're going to call it, there's going to be a different letter. It's going to be M. They're going to call it slope. Slope is a little, it's the same concept, but you find it a little differently. Whenever it's just a constant, kx, like this, it is the unit rate. Next year, they're going to add some to this. It's going to be a little different, but very similar nonetheless. So what's the unit rate? What does k equal? We found it up here. What's the unit rate?
60.
Wrote it there, 60. So the equation is y equals k is 60. 60x. And if you notice, we already had half of that right there. Any questions?
7, 8. No, it's an X.
It's an x, I'm sorry. I'll rewrite it. Any other questions? Let's look at this next one. Predict the movement between points on a graph. So, like, I can't predict for you. You predict on your own. So predict. When you do this, look at the graph before. Look at the other side of that paper. There's a graph there. Look at it and compare it to your equation. Now look at the equation we have, y equals 60x. I'm going to write that here. What it's telling you to do, all right, predict, how is this, whenever I draw my line, how is it going to move? That's what you're predicting. Yeah? So maybe up, I heard. And like how much up? How much right? How much left? There's really no wrong answer because it's a prediction, but when you're done, go back and check your prediction to see if it was accurate. So right now, pause the video, answer 4 if you didn't answer it already, and then you could go back and check it at the end to see if you did it right. Let's talk about this, and I've actually done a lot more than I meant to, but this is a lot of information you got today, so I think you need the help, so I'm fine with that. Let's, before we can make our line though, we need a table. So what I'm going to do is an x and a y. Here, let's just do it this way. Sorry. And it's being stupid. 1 second. There we go. Sort of. And moved everything but the table. Oh, sorry about this. I should probably pause the video. So, but I didn't. Sorry. We're almost done though.
That's uneven.
I know.
I mean, so is he ready? Me too. That's all my.
Oh, goodness. All right.
Are you having trouble with this, Camille?
Yes. What gave it away?
Yeah, really. The fact that you're going.
All right. So there's sort of there's a table in kind of the right place. This is not quite as easy to manipulate as like Microsoft Word. We always put our X here and our Y here. So go ahead and do that. Now for your table, all you need is like a T with an X and a Y. Mine's a little better because I did it on here. All right, so could you have, let's see, X is our number of hours, Y is the minutes, I believe. Could you have 0 hours? Could there be 0 hours?
Yeah.
Yeah, how many minutes would that be?
0.
0. What's another number of hours I could
Well,
have?
it could be anything under 1 hour, like 59.
Yeah, technically, yeah. We're going to say just completely 0, though.
Okay.
Good point. So we could have 1, in 1 hour, how many minutes? What's 1 times 60?
60.
60. What about 2?
120.
120. What about 3?
180.
180. And so on. Now, if you remember, you already have a table here. We actually didn't have to do that. I just wanted to put one right next to the graph. So let's graph this now. We're going to say that this is the x-axis. This is the y. And I'm not drawing in the middle. I'm going to just use one quadrant. We'll get with 4 quadrants later. So 0, 0 is right here. That's this point. What's the next point? Over 1, up how many?
60.
60. Now that's going to be tough, isn't it?
Maybe.
Yeah, so let's do this. Let's count this by 30s. That's really not the best thing to do, but it's the only way to do this for now, so. What's 90 plus 30?
120.
120?
150, 180,
200.
200.
All right. And what I do is I counted by 30s. All right, so 1 and 60. So over 1 up how many? 60. So right there. What's the next line? Point. 2 and 2 and how many? 120. So right there. So it looks like the dots are going to be sort of like this. You see the pattern? Up 2 over 1 every time. So what can I do to show that it's these numbers but anything in between?
What is that? Under the 180.
90. No. Sorry. 150. 150. What can I do to show that it can be anything in between these numbers? Not just the points, but all this space here, all this space here. What can I do with the dots? Look on the other side. What did we do?
A line.
Yeah, we draw a line to connect the dots to show that it's not just those points, but anything in between. And then it could be anything bigger, so we draw an arrow. All right, any questions? Any questions?
No.
All right. I actually did a lot more than I meant to. That's okay, though. You still did a couple of things on your own. Tomorrow, we're really going to practice this a lot and hopefully get it direct variation and graphing and stuff.